What you're seeing here is the world's first outdoor marine cloud brightening experiment. It's taking place over the Great Barrier Reef, Australia. And what we're doing is we're replicating a natural process where wind, waves, bubbles in the ocean generate tiny little water droplets that evaporate in the atmosphere, and the salt crystals are left behind. Tiny salt crystals, the size of a virus. They're mixed up inside the atmospheric boundary layer, and inside a cloud, every single droplet needs one of these little tiny aerosol particles to condense around and form a cloud droplet. Over the oceans, the numbers of these cloud condensation nuclei are often limited. More cloud condensation nuclei lead to brighter clouds. Brighter clouds reflect more sunlight back from the Earth and cool the surface below, in this case, the ocean. Before I take this story any further, I'd like to pay my respects to the traditional Indigenous owners of sea country on the Great Barrier Reef. I pay my respects to their elders, past, present and future. The Indigenous people of the reef have been looking after their sea country for tens of thousands of years, living in harmony with it. But this very same ecosystem is now under severe threat. Since 2016, we've had 5 mass bleaching events hit the Great Barrier Reef. These are marine heat waves that cause coral bleaching on an immense scale, as you can see in these maps. However, just this last summer, we've had the most severe bleaching event on the reef to date. Just to give you an idea of this, the yellow in this plot is medium levels of bleaching. The oranges, the reds, they're high, very high, extreme levels of bleaching covering nearly the entire Great Barrier Reef. Some of the reefs that some of my colleagues surveyed had 97, 98% of the corals bleached. And if we look forward in time, you can see in this plot the global temperature. So the warming of the planet, this is shown for the southern hemisphere summer due to anthropogenic warming. We had a couple of moderate bleaching events back in the late 90s, early 2000s, but you can see very clearly that we've passed a threshold now. It's too hot for the Great Barrier Reef. And if you look at where we're going, there's a certain amount of warming that's baked in no matter what we do to reduce emissions. You can see the Paris climate change target there, far above anything that the reef has experienced so far. You heard earlier that we could be going to as much as 3, 4, 5, 6, 7 degrees of warming, a future that's completely incompatible with coral reefs. But how can we intervene in an ecosystem that's the size of Italy? You need energetic leverage. And with cloud brightening, when you produce one of those tiny little aerosol particles, the size of a virus, that's just a sea salt crystal, and it's incorporated into a cloud and it grows to a droplet, it increases 500,000 times in size. Nature's putting in the energy for that to happen. We don't have to do anything except produce that 30 nanometer droplet. That cloud then reflects the sun's energy back into space, giving even more energetic leverage. And so this is how we can affect something as big as the Great Barrier Reef. Clouds are a very important part of the Earth's energy budget. Globally, they reflect about 20% of the incoming solar radiation. But any individual cloud can reflect up to about 90% of the incoming energy. What you see here are ship tracks. And this is how scientists first discovered the effect of cloud brightening, by wondering what these strange things they were seeing in satellite images were caused by. In this case, the extra cloud condensation nuclei are coming from ships passing below the cloud. So large container ships, the exhaust has lots of small particles, including sulfur, and these are effective cloud condensation nuclei. So you can see the brightening of the clouds in these images. If you think I'm crazy, hopefully this might convince you that it's a real thing. So this is from the IPCC, and the reds and oranges there show anthropogenic changes that have led to warming of the planet. The blue show changes that us humans have done that are reducing the temperature of the planet. And as you can see here, the extra aerosols, which are acting as cloud condensation nuclei, are inadvertently brightening clouds all around the planet right now, and offsetting about 40% of global warming. 40%. It would be 40% warmer if we weren't inadvertently cloud brightening at the same time as we're releasing greenhouse gases. You note the uncertainty bars are quite high, and the uncertainty around the interaction of these aerosol particles with clouds is pretty much all of the uncertainty that we have in the total human forcing. And it's also the biggest uncertainty we have in global climate models trying to predict the future. Why is it so uncertain? Because we haven't had any of the sort of experiments that my team are now doing in Australia to really understand the complex cloud microphysical processes at play. We know overall that there's a fairly strong cooling effect, but not exactly how strong it is under different types of atmospheric conditions and different types of clouds. So in Australia, I lead an international team of over 50 researchers. We're investigating whether using this sort of technology to replicate the natural production of sea spray and brighten clouds over the reef can reduce the ocean temperatures enough to mitigate coral bleaching and to improve the outcomes for the coral. We've developed the technology and the engineering sufficiently to conduct these scientific experiments at a very small scale, just impacting individual clouds or a few clouds to understand how they respond. We're going a long way to proving the underlying hypothesis, but there's still a lot of work to do, especially in understanding how you could potentially scale this up to implement it. We've been doing this over the last 4 years, gradually increasing our experiments in scale and ambition. These experiments are conducted in one of the most regulated marine estates in the planet. The Great Barrier Reef is managed federally by the Great Barrier Reef Marine Park Authority, and all of our research needs a permit that involves consultation, input from Indigenous owners of the reef, and the public at large. We only conduct research, in fact, with the express permission of the traditional Indigenous owners of sea country, where we do the work. The results so far are quite encouraging. The state-of-the-art computer modelling that you can see here shows a future climate under a scenario consistent with meeting the Paris climate target. You can see in the dashed line there the projected trajectory of coral cover on the reef, and in the solid line, the projection if we had marine cloud brightening. So essentially, this is having strong action on climate, which of course, I'm sure everyone here knows we don't have yet, but we're hoping to get, and also marine cloud brightening, and it's enough to stabilize coral cover trajectory on the reef going into the future. That bridge from now into a more sustainable future. However, there's a big caveat. Now I'm showing you a climate change scenario that's more consistent with business as usual. We don't make dramatic cuts to our greenhouse gas emissions. Cloud brightening still helps, but it's only able to stabilize coral cover on the reef for a few more decades. And this is because you can't just keep doing more cloud brightening and getting more cooling. There's a limited window there that can be exploited that only exists under certain atmospheric conditions, which we're lucky that we're convinced that we have over the reef during summer when these marine heat waves occur. But you can't keep doing more and getting more and more cooling. So the two have to very much go hand in hand. We still have a lot of work to do. Our future research program is going to be concentrating on looking at the potential for unintended impacts, at how we could scale this up. We still need a technology improvement of about an order of magnitude in the output before we could even think about affecting a big enough area to start to cool down water. And we need your help. We need societal support for these kind of interventions. They are controversial, and we can't ask for societal support for something that people have never heard of or that they don't understand. So one way that you can help is by educating and talking to your friends and family and encouraging them to learn about this research. The other way you can help is to pressure your governments to reduce greenhouse gases. Regardless of the cloud brightening, the Great Barrier Reef has no future if we can't dramatically reduce globally our greenhouse gas emissions. My son is learning to snorkel now, and I'm not willing to leave him a future without coral reefs. I hope you're not either. Thank you.